we are going to look at 10 laws of Boolean algebra. That's right, there happen to be 10 laws. And the purpose of these laws really is to allow us to simplify a Boolean expression and ultimately to simplify a logic circuit. Because, I mean, really, you want to make a logic circuit when you actually build a thing. You want to do it with as few logic gates as possible. Just cheaper, easier, and so forth. So 4 of the laws, we're going to start with the AND gate laws. 4 of the laws concern AND gates. 4 of them concern OR gates. And then there's a couple of other just little odds and ends rules. So here is an AND gate. You have to imagine I have a switch called X going to this AND gate. And imagine that the other input to the AND gate is 0. In other words, one input is grounded, right? That's 0 volts. The other is a switch called X. What do you suppose the output of this AND gate will be? Well, are you thinking about it at home? Yes, the output is 0, right? Because if I can flip the switch on and off all day long, it doesn't matter. If the other input is 0, I'll always get a 0, right? The only way you get a 1 out of an AND gate is if both inputs are 1. Hey, that's the first law. All right, let's look at the second law. Oh my God, that AND gate is looking really funky there. All right, so let's say I have another AND gate, a switch going to it. This time the second input is powered. In other words, it's a 1. What do you suppose the output will be? Well, the output has got to be X. In other words, if X is a 1, I'll get a 1 out. If X is a 0, I will get a 0 out. The output is whatever switch X is because the other guy is a 1. All right. Let's look at the third AND gate law. Again, I have a switch named X. This time I've decided to take the other input and run the wire also to that same switch. Can you see what's going on here? So they're really both X. I have X as both my inputs. Guess what? The output will be X. Yes, if X is a 1, these guys will both be 1s. I'll get a 1. If X is a 0, they'll both be 0s. I'll get a 0. So the output is whatever X is. And the last AND law says if you have a switch named X going in, and the other input is not X, that's a little NOT gate right here, the output will be, you're thinking about it at home, will be 0. All right, so let me just write them on the side here. X0 is the same thing, or it simplifies to 0. X1 simplifies to X. X, in other words, I have X going to both inputs, simplifies to X. And X not X simplifies to 0. And again, I hope these really make sense. This says if X is a 1, then not X would have to be a 0. I'd get a 0. In other words, one of these guys is going to be a 0. I'm going to get a 0 out of there. All right, stay tuned for the OR laws. Now let's take a look at the 4 OR laws of Boolean algebra. So, of course, these are going to involve OR gates. And let me just draw a few OR gates right there, or let's just do one at a time. That's an OR gate. So again, let's say I have a switch called X. I could, of course, call this anything I want. And let's say the other input is a 0 to my OR gate. So in other words, it's grounded. What is going to be the output of this OR gate? And again, I hope you're thinking about this while I'm doing this. The output will, of course, be an X because to get a 1 out of an OR gate, or if you think about it, if switch X is on, I will get on or a 1 coming out. If X is 0, I'll get a 0 coming out of my OR gate. All right, so the next one, you probably even can guess what the next input will be. If I have X, and what do you think the other one's going to be? Oh, you guessed it. If I have X, a switch called X, and 1 going in other words, the other input is powered, well, I am going to get a 1 coming out. It has to be. All you need is 1, 1 in an OR gate, and you get a 1 coming out. And the third case, again, I bet you can probably guess at what the third case will be. I have switch X going in, and I have the other input also tied to that same switch X. The output is, of course, X. Right, if X is a 1, I get 1 out. If X is 0, I get 0 out, and so forth. And the last case, and you probably know what this last case is going to be, very similar to the AND laws. If I have X going in, and then a little NOT gate here, so this is not X going in, what do you think? I get a 1 out, right? Because if I have X and its opposite, one of these things is going to be a 1, and that is sufficient to get a 1 out of my OR gate. So I hope I've said OR gate all along. So let me just summarize these rules on the side here. X OR 0 results in or is the same thing as X. X OR 1 is a 1. X OR X is an X. X OR not X is a 1. Now I happen to be using X for my switches, but I could call the switch anything, A, B, C, D, what does not matter. All right, 2 more laws to go. Stay tuned. So we've got 2 more laws to go, and the 9th law, very easy. The 9th law just says if you have a switch going into a NOT gate, the official name for this is an inverter gate, and then you run that through another NOT gate, guess what? The output is the same thing as the input. In other words, coming out of the first one, you have not X. Coming out of the second one, you have not X. Guess what? Not X is the same thing as X. All right, 1 more law to go. So let me just write this. Not X is the same thing as X. And the last law, maybe I won't even draw the circuit for it. The last law, sometimes this is referred to as the consensus theorem. It's if you have a switch named X ORed with not X and something else, the output, now this is going to seem maybe a little bit weird, the output is the same thing as saying X OR Y. Let me just explain this here. So in other words, if this is an OR gate here, if X happens to be true, if X is a 1, this statement will be true. If X is a 1, this will be true. Or, in other words, if X is not true, this statement will be true if Y is true. I know that seems very strange. So again, if X is a 1, I know this is going to be true. The other way it's true, if X happens to not be a 1, will be if Y is true. That's why it simplifies to X or Y. Right? Because if Y is true, then this thing will be true if X is true. We already knew that. But if X is not true, in other words, if X is a 0, then not X will be a 1 and it'll be true. Yeah, it's a head scratcher. You have to think about this. Sometimes I tell students this law is, I think of this as if you have something and its opposite, right? X and its opposite with some other junk, just cross out the opposite. I could write this the same way. If I have, let's say this was not X and this was X, and I could even write other stuff next to it, A, B, C. So if I have something and its opposite, in other words, X and its opposite, I can just cross out the opposite one, and I'm left with, in this particular case, it would be not X plus A, B, C. Again, this is called the consensus theorem. So on the last slide, and I'll just hang with me, I will summarize all 10 laws, just another minute, so stay with me. So here are my 10 laws of Boolean algebra. In the next video, I'm going to go over how to use these laws to simplify any logic expression that you have. But write these down, make sure you know these 10 laws, and hopefully they make sense to you. There's, again, 4 AND laws, 4 OR laws, and then of course there's this double negative, the not, and then the last one, which is always a little funny, is sometimes called the consensus theorem. If you have something and its opposite with something else, you cross out the opposite, or the guy with the something else. And that's it.